Okay, so we have the 2009 integrals accumulator question. This is a question number 2, so you can definitely use your calculator on this. In fact, not only can you use it, you will need to use it. So like I said, in these integrals accumulator questions, you're going to be given a rate of change in the context of a problem. So this question says the rate at which people enter an auditorium for a rock concert is modeled by the function r, given by r of t equals 1380 t squared minus 675 t cubed for t between 0 and 2 hours. R of t is measured in people per hour, and no one is in the auditorium at time t equals 0 when the doors open. The doors close and the concert begins at time t equals 2. Our first question says how many, so that's one of those key words that we talked about in the review, how many people are in the auditorium when the concert begins. So we want to know a total accumulation of that rate. So we're going to do the integral from 0 to 2 of r of t dt. And since it's a calculator question, we're going to have the calculator do the work for us. And the number we end up getting is 980 people. Okay, and that problem is as simple as that. How many points is this worth? This question is worth 2 points. We get 1 for the integral and 1 for the answer. The second question, B, it says find the time when the rate at which people enter the auditorium is a maximum. So find the time when the rate at which people enter is at a maximum. So in this case, we want to know when the rate is at a maximum. Okay, and this is again going to be an absolute maximum. And the reason we have an absolute maximum is because we have a closed interval. But first we need to find our critical points. And to find our critical points, since we want to know when the rate is at a maximum, we have to do the derivative of the rate and set that equal to 0. So what we're going to do is we're going to find r prime of t and set that equal to 0. Now if you're using a calculator on this, have the calculator do the work for you. You want to graph r prime of t and then find the 0 on your second trace function. This occurs at t equals 1.362 or 1.363. You can do it either way. So this is our critical point. For an absolute max, though, what we're going to do is we have to test the critical point and the endpoints in a table. So the table that we're going to have is t and r of t. Our endpoints are 0 and 2, and then we're also going to test this critical point of 1.362. And we're going to plug each of those back into the rate. Again, use your calculator to do this work for you. And we will get the values 0, 854.527, and we'll get 120. So the question is saying find the time when the rate at which people enter is a maximum. We would then say the max rate occurs at t equals 1.362, or we could say t equals 1.363, and then that would be hours. This question is worth 3 points. They're going to give you a point just for considering where r prime of t equals 0. So you can count a point for that, and then finding this t value is a point. And then your justification with the table. So basically all of this will give you your third point. So that is question B. So at this point in time, we're already at 5 out of the 9 points. Let's move on to question C. Question C, the total wait time for all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. This function W models the total wait time for all the people who enter the auditorium before time t. The derivative of W is given by W prime of t equal to 2 minus t times our rate function R of t. Find W of 2 minus W of 1, which is the total wait time for those who enter the auditorium after t equals 1. So we want to find W of 2 minus W of 1. For this question, what will connect our two function values to our derivative is the fundamental theorem of calculus. We can do the integral from 1 to 2 of W prime of t, and that will equal W of 2 minus W of 1. Here's the good news. We can get this integral value here on the calculator. So we plug that into the calculator, and this comes out to be 387.5. And this is a 2-point question. You get a point for the integral, and then a point for the answer. But the key piece in this one is the fundamental theorem of calculus. On to the last question, question D. On average, how long does a person wait in the auditorium for the concert to begin? Consider all people who enter the auditorium after the doors open and use the model for total wait time in part C. The key word in D is on average. So what we're going to use is we're going to apply the 1 over b minus a times the integral from a to b of f of x dx. But we need to apply it to this scenario. So actually, I take that back. We're not going to apply this. We're not going to apply that. This is not that kind of average. So this is actually the average wait time per person. So we're actually measuring two different things. Sorry about that. We are actually going to take our total wait time, which we got from the previous answer, from 0 to 2 of W prime of t, and we're going to divide that by our total number of people who entered the auditorium. So we have to actually use the number from part A. So we're going to multiply this by 1 over 980. This will give us 0.775 or 0.776. So we could say, on average, a person waits 0.775 hours.